Hello everyone, welcome to the episode 12 in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. We briefly discuss topics such as on this list. First, I am very proud of the successful application of pattern-driven diagnostics to macOS 6, which resulted in a new training course available online in PDF and in paperback. My goal today is to demonstrate how different patterns appear and interact together in a code dump found on my system. I have some code dumps on my system. And they were all created by root user. So in order to open them, I need to use this command to elevate privileges. So I just opened the first code dump from the list. It is one of my local applications related to 3G modem that crashed. So first of all, we try to get backtrace, and what we see that it is incorrect and truncated. So there is no usual start or main function. So we might think that there was some kind of buffer overflow, local buffer overflow that changed return pointer, return address. So, and therefore we are not able to get stack trace. So what we do, we now try to dump raw stack region and analyze execution residue. So for this, we dump the first 1,000 addresses. This is actually 32-bit application. So we use ESP register. So from the current stack pointer, we dump execution residue. And what we try to get some kind of partial stack trace to get better stack trace. So first of all, we see that the last function call was L2 packet receive. So we try to find anything here. Like, for example, here we see, let's actually dump. So this is our stack pointer. So it is points somewhere in this region. And therefore we try to get stack trace So I did that. I tried to find some fragment based on saved EBP pointers. So basically, I was able to do that starting from here. So we see that saved EBP address just after return address. So we then go down at points here. So the next frame is this one, might be this one, and saved EBP is this one, A98. So it points to this function, pickup read BPF. So the next frame is C08, and it is here. So it points to this function, and it is very close to what we see from Truncated Stack Trace. And then it points to this address, and we see another L2 packet receive. And then the saved EBP points to another region that doesn't have any return address. But in between, we see some kind of a regular buffer. So for example, if we copy this address and try to print it as a string, we get some ASCII-like string indeed. So we found some possible partial stack trace, but there is a gap, and this gap can be tied to start and main. So here's main is linked to thread start function. So I put these all slides that I publish afterwards, where I outlined partial stack reconstruction. So again, we think that there was possible local buffer overflow because we identified a regular ASCII region. So this was a very small case study. I wanted to show how different core dump or crash dump analysis patterns can be recognized in core dumps. And finally, as usual, here's our ban add slide. So next Monday, there's free webinar on systemic software diagnostics. And then we have some forthcoming training sessions. And also we plan three-dimensional debugging training forthcoming in December. That's about live debugging on Windows. All live debugging topics that are not covered in accelerated and advanced Windows memory dump analysis. More details will be announced later. So thank you for watching this episode. Please later check out the slides and recorded video from debugging.tv. The next episode is scheduled for the 10th of September. Thank you very much. Bye-bye.